Module 1, Section 1. This time we're going to be doing Objectives 6 and 7. Objective 6 is plotting whole numbers on a number line. Okay, so now these next three number lines, what do you notice? What do you wonder? Okay, so these are kind of ambiguous questions, but you can notice that they all start with 0 and they all have the same size spaces, but they're numbered differently, right? Okay, they're the same length, but they end on different numbers. They seem to be connected. There's 7s, there's 5s and 9s, but the numbers are different, right? So what do you wonder? Maybe what they could be used for. Maybe why they're different sizes. All kinds of different things that you could think about in that respect. Okay, so there's those same three number lines again. Now here's the question. Choose the best number line above to plot each number given, and then plot and label each number 600, 6, and 60. Okay, so let's take a look at that first number line. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Can you see that 6 fits on that one, right? It's right here. What if I had to use that top number line to graph 600? If this ends at 10, it would have to go a very long ways in the right direction to get to 600, wouldn't it? And to get to 60. So by numbering them differently, like the bottom two, you can make big numbers fit in the same spaces. Okay, so let's back up a little bit. Okay, so 6 is going to fit right here on 6. Okay, could I put 6 here someplace in between 0 and 10? Absolutely. Could I put 6 someplace between 0 and 100? Absolutely. The difference, though, is you're guessing on these two. You don't have an exact place to put it, do you? So somewhere around here maybe, somewhere around here maybe, but you don't know. You're just guessing. Okay? But the top one has a 6 for absolutely certain. Okay, now to plot a number, you put a dot directly on the number line where that number is. Okay, you don't float it above, you don't put an X, you just put a dot directly on the line. If you put it above the line, like up here instead, that is your scratch work space of a number line. That's not the correct answer yet. That's just where you're working things out. So that's not correct. Right on the 6. There we go. Okay. Now the second number line, so 10, 20, 30, 40, etc., counting by tens. Let's put 60, because it is a multiple of 10. It's 10 times 6. So it goes where 60 is. And you can see it because it's already labeled, right? And then the 600, that goes on the last one, because you see a 600. Could I put a 600 on the second number line? You could, but you'd have to extend it a long ways. What you see doesn't have a 600 on it, so it's not very useful for that particular thing. Okay, now on this number line, you have a dot, and you have a 0 and a 200, and that's it. So you can see that this isn't completely helpful because you don't have all the smaller sections, if you will, of the number line to show you exactly where that dot is. Okay, if I would have all of these marks, I'm going to erase these, it's just going to look really bad for a second. Okay, if I'd have all of these marks all the way across and I'd be numbering them by a certain thing, whoops, I missed, it doesn't matter. Okay, if I knew I was counting by, I don't know what that would even fit, tens maybe? then you could figure out where the dot is a little bit closer, couldn't you? But the way it is, you don't know exactly. Okay, so what I'm going to do is just take a guess. We want to have a guess that's too low, a guess that is about right, and a guess that is too high. Okay, so if 0 is way down here, 200's up here, we know the dot's closer to 200 than it is to 0. So a guess that's way low, let's say 100. Okay, is that close? Not really, is it? Because 100's going to be here, halfway through. Okay, so a closer guess that's too low might be halfway between 100 and 200, which would be 150. So that's still too low, but it's closer. Okay, something that's too high. Okay, let's say maybe 190. Can you see how that might be too high? Because if I take this difference between 150 and 200, and I'm going to count by tens, because 190 is also counting by tens, I'd have to go 160, 170, 180, 190, 200. Okay, so 190 is clear up here, and that's way too far. So now you can see what I mean by the scratch work goes up above, can't you? Okay, so let's say 190 is too high. 180 is probably too high as well. Something about right? I'm going to say 170, because when I have that broken down right here, if this is counting by tens, there's 10, there's another 10. So 50 plus 10 is 60, plus another 10 is 70. So I'd say that's pretty close. Now here is what it is exactly. So I was close, but I wasn't exact, was I? So when you don't have all those smaller lines, your guesses might be a little bit off. So what I had done is say there's 100, there's 150, and then when I broke this section up, I didn't really do it correctly. I just kind of did it fast and wasn't really paying attention to what I was doing exactly. So what would we say? It's a little bit more than 175. So maybe 180. You know, that gets you a better estimate, doesn't it? So the more accurate you can be with your lines, your little intervals here, okay, the more accurate you can be with guessing where your number is. Okay, the top part here says to graph a whole number on a number line, determine an appropriate scale or accounting pattern for the number if needed. Then find the number and mark it with a dot. Okay, so that's like the 3 number lines we were talking about at the beginning. Let's see, let's go back. Those. So we have different number patterns, don't we? So here, this one, the top one is counting by ones. The next one's counting by tens, and the last one's counting by hundreds. So it just depends on what number you're graphing on what you want to count by. Okay, so that's considered the count pattern. Okay, it's also considered a scale. All right, so example 10, graph each of the sets of numbers on a number line. If needed, label the tick marks. Okay, we need a comma right there. That's going to drive me crazy. Okay, these little marks here are called the tick marks. Okay, and you can see they're already labeled, but that's because they did this one. So let's take a look at what they've already done. We want to graph 7 and 9. So they started counting at 0 and they ended at 10. There's your dot on 7 and your dot on 9. Okay. Now on this next one, if we use the exact same scale or the count pattern for the top line and the bottom line, started at 0, it would be 11, 12, 13, 14, 15. You just keep counting until you got to 36. That would be kind of nuts, wouldn't it? It would be a huge line. And we don't need to do that. We just are going to count differently. So in this case, our count pattern, we're going to start at 30. Personally, I don't like doing that as much. I like having a 0 on my number line, but it doesn't matter. Okay, this arrow means it goes forever in that direction, and this arrow means it goes forever in the other direction. So over here, it'll eventually get to 0, won't it? So yeah, we don't need to have it on the graph every single time. You just don't want to be lazy, and I'll show you what that means here, and when we're doing our own. Okay, so they've also not numbered every tick mark. So if we did a 30, and then 35, and then 40, 45, and 50, your number line doesn't get all messed up because you have so many numbers in here. So that'd be 31, 32, 33, and see how tiny you have to write? And that's just ridiculous. So we're going to skip a couple and count by 5s instead. Okay, so you can see they've got 36 and 45 marked here and here. All right, so 2,250 and 5,000. So we want to be certain we get both of these numbers on the same number line. So we're going to start at 2,000 and we're going to end at 5,000. We can get both numbers. Okay, so 2,250 is that dot, and 5,000 is that dot. Okay, let's try our own here. Okay, you have to draw your own number line. Okay, so number lines have arrows on both ends, and they have marks all the way along it, equally spaced. These are pretty close. Okay, and you don't have to have 10 marks, or you don't always have to have counting by ones. You can get original. However, like I said, don't get lazy. Okay, so if I want to graph 3 and 5, let me show you what not to do. Okay, here's 3 and there's 5. Okay, that's not cool. Okay, you don't want to count by weird numbers, and you don't want to leave numbers out. Okay, so let's use the number line I have up here at the top. If I start by 0, I'm going to count by 1s. So that would put 1, 2, 3. That would be my 3. Okay, there are 3 numbers you absolutely should have. Okay, I like to start with 0, like I said, so that's my first. And then what I'm counting by is my second, and the number I'm graphing is my third. Okay, if you don't start with 0, let's look over at their second example. You need to have at least 2 numbers so that you can see what you're counting by. So if we had a 30 and a 35, I want you to graph or label the dots. Okay, that's just my preference. It's not absolutely necessary, but that way you can leave off a lot of the numbers because you know exactly what we're talking about. Okay, so back to our problem. We have to put a 5 on there as well. So there's a 5 and our dot. Okay, the next number line, 156 to 914. Okay, so we're going to count by bigger numbers, aren't we? Okay, if I did a 0 here and I went to 1,000, I think I can do that. Let's see. So 100, 200, 3, 4, 500, 600, 700, 800, 900, 1,000. Yep, looks like I can fit it in there. Whoops, one more 0, huh? And I'm counting by 100s. Okay, so that would put 156. If this is 100 and that's 200, 156 is a little bit past halfway. 150 would be halfway. Okay, and I'm going to label that so then I know exactly where it is. Otherwise, you'd be guessing like we did on that one problem. And you might be close, you might be too high, you might be too low. Okay, 914. So if that's 1,000, here's 900. And 914 is going to be closer to the 900 than it is to the 1,000. And I'm going to label it. There you go. And our last one here. So we have 1,000 and a 5,000, but it's bigger than 5,000, so let's go up to 6. Okay, so if I start at 1,000 here, then there'd be 2, 3, 4, 5, 6,000. Okay, and I'm just going to go ahead and label all of these because they're spaced out far enough that it's not going to mess us up too far. Okay, now 1054. Okay, that's not the correct way of saying it. 1054. 1054 is very close to 1,000 and not very close to 2,000, right? So we're going to put way down here and 1054. Okay, so 5,489 is going to be somewhere around there. Okay, that might be a little bit short, but that's okay. It's close. The idea is just to get it in between the right two tick marks on your number line and get used to drawing the number lines. Okay, so section 7, compare whole numbers using inequality symbols. So let's look at the number line that they have here. Notice that numbers get larger as you move to the right of a number line. Okay, so you started with 0, and your numbers get bigger, 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 bigger all the way across. So we end up on this particular one at 500. Okay, do we know what they're counting by? Not necessarily. Could we figure it out? Yeah, probably. We might need to here in a minute. Okay, so you can use a number line to compare two numbers. If we know the larger ones go to the right and the smaller ones are to the left, you can tell which one is bigger if there are two dots. Okay, so I don't even know what these numbers represent right now, but let's say I had this dot and this dot. Okay, so the red one is smaller than the blue one because the number line numbers get bigger as you go to the right. Okay, so they get bigger this way, right? So that means the blue one is bigger than the red one because it's further to the bigger side. Okay. All right, so estimate the location and label 471 and 417. Okay, so if this is 500 and this is 0, we got to figure out what we're counting by. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. Okay, so if I break 500 into tens, I'm counting by 50. Okay, so that would be 100, 200, 300, 400. Okay, so 471 and 417. Okay, so 471, if this is 450, halfway between 400 and 500, 471 is going to be in between those two, right? So this is 471. 417 is closer to 400 than 500, and it's closer to 400 than 450. Okay, so there's our two numbers on a number line, which means the red one, or the 471, is further to the right, which means it is larger. And the 417 is smaller because it's further to the left. Okay, so now use those symbols to compare the two. All right, so let me explain what those symbols are really quickly. So we have this one, and this one. Okay, the last one, you've seen that one all the time. This is equal, right? So are those two numbers equal? No, they're not, so we're not going to use that symbol. Okay, now the other two, the top one is a less than, and the middle one, the bottom of the two, is a, greater than. How do you tell the two apart? other than just memorizing them. Let me show you a couple tricks. If you have less than, see that L, and see that L, it's kind of just twisted, isn't it? So less than is the L looking symbol. Okay, if you think of this as an arrow, this one points to the left, doesn't it? So left is less than. And right, change colors here, right, because that's pointing to the right, is greater than. Okay, lesser numbers, that should be red, I guess. Lesser numbers are to the left, and greater numbers are to the right. Okay, might be a little confusing, but we'll be doing plenty of them, so you'll get used to it, okay? So now let's write this inequality. We're going to compare it. So we have 417 is smaller or less than the larger one, so 471. And way back in grade school, when you learned how to do these the first time around, remember they talked about the alligator eating a big number? That's still the same. So this is the big number, and here's the alligator eating it, right? Okay, so the big side goes to the big number, the little side goes to the little number. Okay, now this part where you have variables thrown in, don't let it freak you out. This is just talking about how to say things, okay? So if you have a number, A is a number and B is a number. Okay, so for A here, I have one number is less than another number. That's all it's telling you. You just want to say it is less than. Okay, so this is true when A is to the left of B on a number line. We talked about that, right? So let's do it this way. Let's see, this is a smaller one, and the other one is a bigger one. Okay, and B, we're going to use a greater than symbol, so this side is bigger than this side this time. And you say it is greater than B. So that means the bigger number is on the right side of the number line, but you put it first if you're saying greater than. Like I said, we'll do some of these, so no panicking. Okay, now this one is printed really strangely. So this thing right here just looks weird. Okay, so let me rewrite it for you so you can see what we're talking about. What they have done is, see over here on our problems that we have to do, there's a blank. And you want to put the symbol less than or greater than into the blank. But when they did that, it kind of messed up the type of the underline or the blank. Okay, so what this actually was is 5 and 9, and what symbol is going to go in between? And that symbol is less than. Okay, so then it just looks like that instead. It's kind of weird. So 9 is further to the right on a number line, so therefore it's bigger, and you get the big side facing the 9, the small side facing the 5. Okay, so this one as well. So we had 73. How does it compare to 37? Okay, 73 is further to the right on a number line, so it's the bigger number. So the bigger side points to the bigger number. Okay, but you always read it going from left to right, just like we read everything. So 5 is less than 9. 73 is greater than 37. Okay, let's do hours. Okay, if it helps you do a number line, let's do that. Okay, so here we go. We need to get 130 and 120 on the same number line, so I'm going to start with 100, 110, 120, 130, 140, we have the numbers we need, don't we? Okay, so 130 is here, and 120 is right there. So 130 is the bigger number because it's further to the right, which means it's going to have the bigger side of the inequality symbol. So you would read this one, 130 is greater than 120. Okay, the bottom one, let's make a number line. So I'm going to start at 300, and since that's 435, let's just go to 500. Okay, now I know what I'm doing enough that I know how to pick the number lines, but if you don't want to use a number line, you don't have to. If you can do it in your head, that's fine. If you can just totally rationalize, where they're going to go and do it without a number line, that's perfect. Okay, so 345, sorry, is less than halfway because 350 is halfway. And 435 is less than halfway because 450 would be half. Okay, and 435 is bigger, so it's going to get the big side. So it's going to go like this. And you would say that one, 345, is less than 435. Okay, how would you compare large numbers without graphing them on a number line? Can you imagine graphing all of those? Holy cow. 68,435 and 651,312. And it's like, wow. Okay, so we're going to look at them a little bit differently. And let me show you how to do that. Okay, let's start with these two. All right, what I'm going to do is write them on top of each other. Remember how we used the place values in the past? Okay, so here we go. So 6,800, try it again, 68,435. Okay, now I'm going to line up the bottom one. So I'm going to put the 312 in the ones period and the 651 in the thousands, but notice I am lining them up straight up and down with their place values. Okay. Now, by doing that, I can see that this bottom one has a 600 and the top one doesn't have any. Right? So the bottom is over 600 and the top one is just over 000. Okay, so which is bigger, the 0 or the 6? It's the 6. Okay, so that means the bottom number is bigger. Okay, so how would we write that? We would go, because they use that number first, the 68,000 number, I'm going to put it first. And then I'm going to put the 651,312 second. And we know the 651,000 number is bigger. We just figured that out. Okay, let's do the next two numbers. So, those two. So, 456,254 is the first number. Double check that you got the numbers correct. And the second number, because I know it's exactly the same number of numbers, I'm going to line it up exactly. Okay. All right, so now what you're going to do is start over from this side, reading them this way. The 4s are the same, the 5s are the same, the 6s are the same. So the first number that isn't the same is the hundreds place. Okay, so if we ignore the 4, 5, 6 at the beginning, because they're both the same, the top number is 254. The bottom number is just 54. So the top number is bigger. Okay, so we would write that 456,254 is bigger than or greater than 456,054. Okay, so here's example 12, and you can see it's like what we just did. They're just bigger numbers. And again, it's written very strangely, so I'm going to finish that blank so that it doesn't look so weird. Okay, so let's read what they have so you can see their way of saying what I just explained. The largest place value where the digits differ is in the hundreds place. 7 is greater than 0, so blah, 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 blah. Let me explain that one by writing them on top of each other like we did on the other side, or on the other page. So 1700, 1070. Okay, so the ones are the same. This one is not. So the 700 is the top row, and the 000 is the bottom row. 7 is bigger than 0, so 1700 is bigger than or greater than 1070. Okay, so line them on top of each other again. I'm going to do it below because there's more space. So 302,000, and the second number is 300,209. Okay, so the 3's are the same, the 0's are the same, that one's different. 2 is bigger than 0, so the top number is bigger than the bottom number. And top number is bigger than the bottom number. Okay, let's do the ones over on our side. All right, I'm going to write it over here to the side. Here's your first number, second number, lining it underneath. You can line up the commas if you think about it that way, right? Okay, and I'm going to fill in right here with a 0 because we need a placeholder. All right, so looking here, we have 500 and something. Here we have 0 hundreds. Okay, so 5 and 0, that's your first place value that's different. So the 560,000 is definitely bigger, B for bigger, than the 56,000. Okay, so bigger side gets the bigger number. All right, down here on the bottom, I'm not going to be able to fit it off to the side, so I'm going to do it underneath. And 003, lining up the commas, we have a 7,894,300. Okay, so the millions place is the same, 100,000s is the same, 10,000s is the same, 1,000s is the same. This is the first place value that's different. So the 3 on the bottom is bigger. Okay, so that means the second number is bigger than the first one. Okay, ordering these numbers from least to greatest. Wow, we could make a ginormous number line and put them all on there and see which ones are first. Okay, I'm going to do a smaller one just to show you what happens in that case. Okay, so let's say I had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I wanted to put 3, 1, 8, 4, 9 in order. Okay, you could do this without, but let me show you what happens. Okay, so putting a 3 and a 1 and an 8 and a 4 and a 9. Okay, once you put those on your number lines, you know, this doesn't matter which order you put them in or how they order until you look at the number line itself. Because now right here, they're in order. 1, 3, 4, 8, 9. Okay, so we could do that with these messy, huge numbers up here, but that's going to be kind of crazy. Okay, so let's do it a different way. We're going to line them up and down, like we've done on the last few problems. Okay, so 994,942. We have, 9,042. We have 279,104. 9,420. 59,000. Okay, notice I'm lining up the commas, right? Because that lines up your place values automatically. 500,492 and 279,099. Okay, so like I've done in a couple of the other problems, I'm going to put in some zeros for placeholders, just so that I can get everything to have the same number of digits. So everything has 6 digits now with commas down in between the two different periods, right? Okay, so let's look down this first column. That's your 100,000ths place. Do we have any one of those that's definitely bigger than any of the others? Yep, 5's the biggest, right? Okay, so that one is going to go first because that's the biggest. Okay, so that means this one here is going to be first. Okay, so I'm going to cross that one out so we know that it's done. Now let's look at the rest of the numbers in that first column. Okay, 0, 0, 2, 0, 0, 2. So we have 2's will be next, won't they? Okay, so because I know that there are only 2 of them, I'm going to write them off to the side here so I can compare those two all by themselves. So one of them is going to be second and one of them is going to be third, and we just need to figure out which. Okay, 2's are the same, 7's are the same, 9's are the same. There's the first ones that aren't, and 1 is bigger than 0, so this one is bigger than the bottom one. Okay, so that means this one is going to be second and this one is going to be third. Okay, so the 279104 is second and the 279099 is third. Okay, so cross that one out, cross that one out. Okay, now we've got 4 numbers left and it's kind of crazy. So I am going to actually erase, see if I can get it to, that's not what I wanted to erase. I wanted to erase just this number and then these 2 numbers so you can see just what we're working with. Okay, rewriting it might be a good thing. Okay, and now we don't need the zeros in the front anymore either. Those are the ones we added for place values, or placeholders, and we don't need them. Okay, so let's take a look at the rest of these. So straight down this next column, 9005. 9's the biggest. So 94,000 and something is bigger than 59,000 or 9,000 or 9,000, so that's going to be next. Okay, so we have first, second, and third. So now this is going to be fourth. Okay, so that was our first number up here. Okay, so now that one's out. We're still looking at this first column, 0, 0, and 5. 5 is the biggest. Okay, so that one is going to be fifth. So there we go. We're down to 3 numbers. Oh, 2 numbers, I'm sorry. We have the space in between. Okay, so now we're just looking at these 2. Okay, so zeros are the same, 9s are the same. 0 and 4 are different. 4 is bigger than 0, so it's the next biggest number. It's going to be 6th, and that one's going to be 7th or last. So this one is 7th, and this one is 6th. So now we're going to order them. We're going to rewrite them. Order them from least to greatest. Okay. Oh, I did it completely backwards, didn't I? I put number 1 was the biggest, and number 7 was the smallest, and they wanted us to do it backwards. So we're going to start with 7. Okay, so we're going to go 9,042, and then our 6th is 9,420. 5th is 59,000. 4th is 94,942. 3rd is 279,099. 2nd from the last is 279,104. And the very last is 5,492. Okay, so now those are in order. If you wanted to do it in their order the first time, go from least to greatest. Instead of finding the bigger number, you'd be wanting to find the smallest number every time. Example 14. Marley and her friends are playing video games. Here's each player's score at the end of the game. And you see 6 scores, except one of them is missing. So A, you're going to rank the scores from lowest to highest. And then B, Zoe's score accidentally got deleted, but everyone agrees that she's in second place. So could her score be a 6-digit number? Give a couple of examples of what Zoe's score could be. All right, so we read through the whole thing. Now we need to figure out what our plan of attack is. So what I'm going to do is put these 5 numbers in order, and then put a place in between, a space in between those for hers, and then see what it possibly could be, if it's a 6-digit number or not. Okay? Now, let me write them in order down here at the bottom. Or not in order, but line them up. There you go. So it's kind of in order. So 99,450, 99,370. Zoe's doesn't have a score, so we'll leave that one blank, or just not count it. So 101,003, 98,045, and 99,345. Okay. Now here's why I did it highest to lowest before, because when you're looking in the columns, you can see that this one is biggest automatically. So we're going to put that first. And now the 9s are all the same. So then I have to go to the next column. And if I figure out which one's the lowest instead of which one's the highest, it gets really confusing. And I'm not going to show you that way because it will confuse you even more. So let's do highest to lowest, and then we'll just reverse it when we want to write them in order, lowest to highest. Okay, so if we filled in with zeros here because we want to compare, you can see in this row 1 is the biggest, right? So this one is first, and that would be cash. All right, so his is gone. Now let's compare the others. So we have 9, 9, 9, and 9. Now remember that 0 is his. Okay, so I'm going to cross that one out, and I'm going to cross it out pretty well. I don't want to cross it completely. I still want to be able to read what I have, but I don't want to get confused and think I have to use that one again. Okay? So 9, 9, 9, 9. Those are all the same. Okay, let's look at the next column then. Okay, so that one is out. Now the next column, we have a 9, a 9, an 8, and a 9. So 8 is the smallest, isn't it? Okay, so this one is smaller than the 9, the 9, and the 9. So that means this score is the lowest one. Okay, so this one is last place. And I'm going to make that a cursive L so it doesn't look like a 1 in our first. So 9, 8, 0, there we go. So meadow is last. All right, so I'm going to cross that out a little bit more, and now let's look at the next column. Because they're all 9s now, right? 9, 9, and 9. Okay, so next column, we have a 4, a 3, and a 3. So 4 is the highest, isn't it? So of the remaining 3, 4 is next. Okay. So, tell you what, let's go over here on the side, and we'll do 1,000, 100, 1,000, 3 is the top. So we have first, second, third, fourth, fifth, and sixth place. Okay, so we know cash is first. And we know meadow is last. Okay, and we know that Zoe was second. So we're not going to put anything in here yet. I'll erase that in a minute. Okay, so now we have these other 3 numbers. And we found that the 4 is bigger than the 3 and the 3, right? So 4 has to be next highest. So it's going to come in next highest right under Zoe. Okay, so we have this one is going to be next. So 99,450, and that was Marley. And now it's gone. Okay, so now I have 370 and 345. And that's pretty easy to tell which one's bigger. 370 is bigger, right? But if you wanted to cancel out another row because the 3's are the same, you could do that. And then you would have 70 and 45. Okay, so this is getting pretty messy, isn't it? I'm sorry. So the 70 is bigger, which means the 99,370 goes next, and the 99,345 is next after that. So 99,370 was Jonah, which leaves 99,345 for Nixon. Okay, and if you guys have a different way of doing that, be my guest. You can do however you want to. This is just one way to show you how that's possible. Okay, so rank the scores from lowest to highest. Okay, so we're just going to rewrite them in the opposite order. Okay, so 98045, and I'm going to put semicolons in between. Don't want to put commas in between because there's commas in the numbers, right? 99345, 99370, 99450, and 101003. A lot of numbers, a lot of punctuation. Okay, so let's get to Zoe. Her score was accidentally deleted, but everyone agrees she was in second place, which we have. Okay, let's get rid of this thing here. Could her score be a 6-digit number? Okay, if cash has a 6-digit number, 1, 2, 3, 4, 5, 6, and Marty has a 1, 2, 3, 4, 5-digit number, could Zoe's be a 6? So the lowest 6-digit number is 100,000. Does that work? Is it less than cash and greater than Marty? Yes, it is. So that's a possibility, isn't it? Okay, so that's one example. What's another example? What if I was just 1 point less than cash? If he got 101,003, what if Zoe got 101,002? That's possible, isn't it? Okay, so 100,000 is 1. Whoops. Let's get rid of that and say, and 101,002. Are there others? Absolutely. But those are just two that I came up with really quickly for you. And that's the end of Module 1, Section 1, Objectives 6 and 7.